Hi, Cullen. I am doing some of the problems from the decimal division problems that you sent me, 19 through 23. I'm going to work a few of them and then let you learn from this video and then see if you can finish the others successfully without me. So I'm going to do number 19 for starters. This is the way the problem is written, and we're told to find the solution to the nearest hundredth. So before we dive into this, let's remember what that means. You know that numbers have place value, right? There's a ones place or a units place, and there's a tens place, and there's a hundreds place, right? And it keeps going all the way up through the thousands and the millions and the billions and the trillions and the quadrillions and so on, right? There's always a place, and the number that's in that place doesn't actually represent, like this number, it doesn't actually represent 2, it represents 20. We know that. You learned that a long time ago. That's true on the other side of the decimal as well. The names of these places have the same situation where it's a 1 with a number of zeros after it, but in this case, we're changing the number in the denominator of the fraction, right? So we keep that same pattern of adding a 0 with each place, but they're being added to the number in the denominator rather than just being a whole number. Okay, so what you're being asked to do is to round to the nearest 100th place. That TH tells you fraction. But in order to do that, we have to have one more digit after this. And the rule is that we look at this digit. If it's from 0 to 4, sorry, we stay at that number, and if it's from 5 to 9, we go up. And I'll explain that in a little more detail when we get to it. But I want you to know what this tells us, that we need to cut round to the nearest hundredth, means we need one more decimal place beyond the hundredths before we can stop dividing, and then we'll use that digit to round to the nearest hundredth. So that tells us we need 3 decimal places. So with that in mind, let's set up our division problem and go to town here. Now, the problem uses words like divisor and dividend. I find those words are extremely confusing to students, and they confuse me too. They're just big and they don't have any intuitive value to them. So what I like to do is just say one number goes inside the division box and the other number goes outside, because this is how we need to set it up, right? In order to actually do our division, is we have to figure out which number goes where now. This number, 20.82 divided by 4.24, tells us this one goes on the inside, this one goes on the outside. It always works like that. This one goes there, this one goes there. So we set up the problem. Now we have to take care of these decimals. Now here's the situation. We first pay attention to the number on the outside. If that's got a decimal at all, besides just at the end of the number, it's drama. So we have to resolve that. And what we can do is we can jump the decimal. Basically what we're doing is we're multiplying it by 10 for every jump. So we're multiplying this one by 100. But we can do it just by moving the decimals. And so that moves our decimal here, and now our number is 424 instead of 4.24, and we're happy. We have to get rid of the decimal in this number. What we have to do over here is we have to jump the decimal the same number of times. So we did it twice here, we have to do it 2 times here. But it can end up anywhere. It doesn't matter. This number is much more flexible about decimals. This one is not. Once we settle the decimal in its new home, we take it up and we write it right here in the answer so that it will be clear. So here are the rules for this part of the problem. I call it jumping the decimals. And the rule is first the outside, right? This one we fixed, then we did the inside. And on the inside, remember, it's much less fussy. The outside is very fussy. You have to move it all the way to the end of the number. And then this one, you just have to do the same. All right, now we're ready to start the actual division process. And everyone forgets this because long division is a 4-step process and it's hard to keep all the steps in your head. The first step is to estimate. We're trying to figure out how many times does 424 go into this number? And there's no easy way to do that. I don't know my 424 times tables, right? So what I do is I simplify these numbers. And in this case, what I'm gonna do, and there are little tricks that make every problem a little bit different. But in this, what I'm gonna do is I'm gonna cover up the last 2 digits on both. And I'm gonna say, okay, well, how many times does 4 go into 20? Let's try that, right? That's a simpler version of this problem. And that I can do really easily. I'm guessing it's 5 times. So what I'm gonna do now is over here on the side, it's still an important part of the problem. I'm gonna say, let's multiply 424 times 5 and see what we get, and make sure that it's close but not above this number. 5 times 4 is 20. 5 times 2 is 10, plus the 2 that I carried is 12. 5 times 4 is 20, plus 1 more is 21. And look what happened. When I actually multiply this by 5, it's a little too big, isn't it? Because this 24 changes the actual number. It makes it a little bigger, right? When I actually multiply the 24 out as well. So I see now that my estimate was a little too high. And that's fine. This happens all the time, and this is one of the hardest parts of long division, is getting that estimate right. So it's okay to take one guess and then go, no, that's not gonna work. What I need to do is recognize that 5 is too big and I need to go down to 4. Now, how did I know to put the 4 there? Let me show you. Now what we're gonna do is we're gonna go, our first one was estimate, our second one is multiply, right? And these 2 processes kind of go together because we're multiplying in order to estimate. So now what I'm gonna do is I'm gonna take 424 and multiply it by 4, right? I determined 5 was too big. I'm gonna multiply it by 4. I've already written this over here, but I wanna show you how I knew where to put it. 4 times 4 is 16. 4 times 2 is 8, plus 1 more is 9. 4 times 4 is 16. This is the product I get when I multiply 424 times 4. I want this number to line up like this, right? I want it to be right underneath this other number because my next step is to subtract, right? I might as well put that down. Once I figure out where I want this number to line up, then I go right straight up from there, and that's where I put the number up top. This used to drive me crazy when I was learning long division. Nobody explained to me where I should put the number. But you put that lining up with where you want this number to go. So it makes a nice, even presentation. Now we're ready to subtract. All right, 2 minus 6 doesn't work. So we borrow from the 8. 12 minus 6 is 6. 7 minus 9 doesn't work. So we borrow from the, not the 0, we have to go over to the 2, right? That becomes a 1. We give it to this one, that's a 10, but now we need to borrow again, so this becomes a 9. Where am I gonna write it? Right there. Now we have one more to give to this guy to make him 17. Minus 9 is 8. 9 minus 6 is 3. 1 minus 1 is 0. Okay, good. And whenever we get our next number, it should be smaller than our outside number if we did our estimating right. So now, the next step is also a little bit of a mind blower. Our decimal's right here, right? We can add zeros all day long to the end of our number as long as they are to the right of the decimal. So we can add zeros to the right of the decimal. And remember that if you don't have a decimal in your number, you can always add it. Like right here, I could put a decimal right there, right? If your number doesn't have a decimal to begin with, you add it over here on the right side of the ones place. All right, so I'm gonna bring down a 0, and now we go back to the beginning and we do our steps again. We estimate how many times does this number go into that number. I don't know, but I'm gonna simplify this, and I'm gonna say, well, how many times does 4 go into 38? 4 times 9 is 36, and that gives me a little bit more of a buffer for those extra digits, right? Remember how here 5 times 4 was right, but we just had a lot of extra numbers. But if I do 4 times 9 is 36, that gives me some extra space in my estimate for everything to work out. So I'm going to try 9 here, and I'm going to do 424 times 9. That's 16, carry the 1. This is 9 times 2 is 18, plus 1 more is 19. And then oh, wait, I made a mistake here. 4 times 9 is 36. 9 times 2 is 18, plus 3 more is 21. 9 times 4 is 36, 37, 38. So we did get way higher than 36, but we're still good, right? 38, 1, 6. And again, this is where I want my number to line up, right? Because I want it to subtract. And so I line up my 9 with the ones place on that number. Now we're ready to subtract again. Borrowing. 10 minus 6 is 4. 5 minus 1 is also 4. 44, oh, it's so tiny, right? Well, let's bring down again. We've got another 0. You don't have to keep writing the zeros up here, but you can keep writing them down here all day. 424 into 440, oh, that one's easy. It only goes once. Again, I line it up because I want it to be like this, right? So I want that to be lined up. I subtract. And I get 16. Okay, we're getting close, right? I said we need to get 3 decimal places, and we've got 2 already. And we bring down another 0, and I estimate how many times does 424 go into 160? It doesn't, right? We need to bring down yet another 0 in order to make that happen. But what I can do is above this 0, which would be like here, I can say it goes in 0 times, right? Because nothing times 424 is going to be that small. So I now have 3 decimal places, and I can round. My rules right here tell me that if my indicator digit, which is this one, is between 0 and 4, then this digit stays. If my indicator digit is between 5 and 9, then I round up. My indicator digit is 0, so that means I stay, which means the 0 doesn't get to be part of the number, but this 1 stays here. My choices are either to stay with 1 or go up to 2. If this would have been a 7, for example, then I'd say, okay, now we round this up to a 2. But ours is in the low category, so our final answer is 4.91, rounded to the nearest digit, okay? So I'm pretty sure in the original problems, I don't know if you have answers for these. What I want you to do is work them through by hand and then check it with your calculator. Your problem tells you don't use the calculator to solve it, but checking your answer to make sure it's right is different than using it to do the work, right? We're not going to cheat, for heaven's sakes. But I do want you to always check to make sure you got the right answer. And since this one is not multiple choice, I want to make sure that you do validate your work. Okay, that is the kind of problem that's set up like this. And I think 20 and 21 are similar. So go ahead and set them up, jump your decimals, and then follow that 4-step process. I'm going to go on and do number 22, which I copied out already, because it's the different format. And the good news is this one's easier because it's all set up the way we want it to be. So hallelujah, that's good. We just have to deal with our decimals. Again, this is drama. We better jump it. And again, 2 times will take care of it just fine, right? So we do 2 times over here, and then we send it straight up to the answer space. And remember, it's okay if this decimal, you know, if there were more digits down here and this decimal ended up being in the middle of the number, that's fine. We don't have any problem with the decimal on this side. It can just go wherever it wants. But here we have to get it out of that number. Okay, 25 is what we're dividing by for our estimating. I'll write down our steps again. I'm pretty good at estimating by 25s because that's like adding quarters, right? For money. We're pretty good. We know our 25s times tables better than we think. We know that there's 4 times 25 is 100, right? Because 4 quarters is $1. So we're pretty good on those. All right, so does 25 go into 10? No. Does 25 go into 102? Yes, I just talked about that, right? 4 quarters is $1, which is 100 cents. So we can see, oh, okay, so 4 times 25 is going to be 100. So again, the estimating process involves multiplying. So these two kind of blend in together. But once we're happy with our estimate, then we actually multiply. And because this number is a little smaller, I didn't multiply it out over here on the side like I did with our 424 last time. So what I'm going to do now is multiply 4 times 5 is 20. I carry the 2. 4 times 2 is 8 plus 2 more is 10. And again, this lined up just the way I want it. Everything looks good. Now I subtract. And we just get a 2, and now we're ready to bring down. And remember, as long as I have my decimal firmly planted, I can add zeros. But I don't need to yet because I still have one in the problem. Okay, how many times does 25 go into 20? Oops, not at all. So we put a 0 here. All right, now we're going to bring down one more 0. How many times does 25 go into 200? Oh, okay, well this is gonna work out, isn't it? Because 4 quarters in $1, which is 100 cents, so 8 quarters in $2. Let's make sure it works. 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. So we're done, okay? Now, the only problem is, I think the instructions told us to round to the nearest hundredth, and that is, there's the 1/10, that's the 100ths. So since we don't have a digit there, but we're supposed to have a digit there, we can add the 0. So our final answer is 40.80. Remember, we never say 40.80 because 80 is a completely different number. You can say 40.80, or you can say 40 and 81/100ths, which is a mouthful to me. I like to say, and most mathematicians I know say 40.80, okay, but never 40.80. There's our final answer. And I believe that 23 is another problem set up like this. So give those two a try, or give the other problems a try, and see if you can get some accurate results. Again, use your calculator to check your answer, but make sure you do your calculation by hand. Okay, thanks. Let me know how it goes.